You ask an AI assistant a question. A second later, it hands you the exact right paragraph, pulled from 10,000 pages of documentation you never told it to read. No keyword matched, no SQL ran. Behind that moment is a vector database, and it's quietly becoming one of the most important pieces of the modern AI stack. So, let's break down what it is and why it works. Start with what you already know. A regular database is great at matching exact values. Find user 42, get last Tuesday's orders, show every account marked active, but ask it for something close in meaning, not equal, just similar, and it has nothing to offer. Similar isn't a value you can match. It's a different problem, and it needs a different kind of storage. It starts with embeddings. An embedding model takes any input, a sentence, an image, an audio clip, and turns it into a list of numbers, usually somewhere between 768 and 1,536 of them. Each number captures a little of what the model learned during training: tone, topic, style, context. On their own, the numbers look like noise. You can't read them. But to the model, that list is a fingerprint of meaning. And here's the idea that makes the whole thing work. Inputs that mean similar things get numbers that land close together. Picture every input as a point in space. Dog and canine end up as neighbors. A photo of a sunset lands near other sunsets. A jazz clip sits beside other jazz clips. Meaning turns into geometry. And once meaning is geometry, finding something similar is just finding something nearby. That list of numbers has a name: a vector. A vector database is built to store millions of them and for any query, instantly find the closest ones. But there's a catch. The simple approach is to compare your query against every stored vector one by one. That's called k-nearest neighbor search. It's accurate, but it doesn't scale. At 100 million vectors, each with over 1,000 dimensions, a single query turns into hundreds of millions of calculations. Fine on a laptop, hopeless in production. So real vector databases, Pinecone, Weaviate, Qdrant, or pgvector running on Postgres, don't check everything. They use approximate nearest neighbor search. The most popular method is called HNSW. Picture a network of highways layered on top of local streets. Your query enters on the highway, makes a few big jumps toward the right neighborhood, then drops down to the streets for a precise landing. Instead of scanning 100 million vectors, the engine visits only a few hundred. You give up a sliver of accuracy, usually 1 to 5%, and in return, you get answers around 1,000 times faster. That trade is the entire point. Approximate, not exact. Milliseconds, not minutes. So when should you actually reach for one? If you're building RAG, retrieval augmented generation, semantic search, recommendations, or image lookup, basically anything that asks, what's similar to this? A vector database is the right fit. If your questions still fit neatly into where clauses and joins, a relational database is the right call. And if you're just getting started, pgvector on Postgres handles a surprising amount before you need anything dedicated. That's the whole idea. A vector database makes meaning searchable at scale. It takes embeddings, those abstract lists of numbers, and turns them into something you can actually query in real time. And it's fast becoming as foundational to AI as the relational database was to the web.